Now let's just start with the very first topic, which is nothing but called as the surface area of a cuboid and a cube. So let's just first of all talk about a cuboid. So if I'll just take any particular rectangle over here, and if I'll just stack up the rectangles of the same size and the same shape in a vertical pile, then I can obtain a figure of such a type, which is definitely nothing but representing a cuboid. So this is nothing but a cuboid which do have the three dimensions, which is nothing but length, breadth and a height. So this would be the length, this would be the breadth, and this would be nothing but the height of it. Now let us suppose if I am just taking any particular cuboid. For an instance, if I'll take any box which is of the shape of the cuboid, and if I'll just open all the sides of the cuboid, then I will get a figure which is nothing but of this form. As you can see over here that if this is nothing but a cuboid and or it is nothing but a box which is of the shape of the cuboid, and if I just have opened all the faces of the cuboid, then I'm just getting such type of a figure. Now as you can see, if I'll just give the dimensions to them, that is L, B and H, then definitely first of all it do have the 6 faces. Now you can see over here the faces are mentioned as 1, 2, 3, 4, 5, 6, and all of them have the specific dimensions, that this is the length, this is the breadth, this is the height. So L, B, H are actually representing the length, the breadth and the height. So if I just wanted to find out the surface area of the cuboid, so that would be nothing but is equal to this area of each rectangle which is over here. So we can say that the surface area of the cuboid is actually nothing but the area of the rectangle 1 plus area of the rectangle 2 plus area of the rectangle 3 plus area of the rectangle 4 plus area of the rectangle 5 and plus the area of the rectangle 6. And we know that what is the area of the rectangle? Area of the rectangle is nothing but length into breadth. Now using that particular concept, let us suppose if I'm just calculating the surface area of the cuboid, I'm just plugging in all the values which are or we can say that I'm just plugging in the dimensions that are given to us in the previous figure into the formula of the area of the rectangle, and from that I am getting the answer as nothing but 2 into L into B plus 2 into B into H plus 2 into L into H. Means we are getting L into B 2 times, we are getting B into H 2 times, we are getting H into L 2 times, because in total we have the 6 rectangles. So they are nothing but representing the area of the 6 rectangles. So at the end we are getting the sum as nothing but 2 into LB plus BH plus HL, as you can see over here, where LBH is actually representing the length of the cuboid, the breadth of the cuboid and the height of the cuboid. So if we are just talking about the surface area of the cuboid, so what is the surface area of the cuboid? Surface area of the cuboid is nothing but 2 into LB plus BH plus HL, where L is the length, B is the breadth and H is the height. So always remember this formula, because using this formula we are going to do a lot of questions that are related with the surface area of a cuboid. Now let's just move on further and talk about the cube. Now what is a cube? Let us suppose if I'm just taking this as my figure. Now you can see over here that in place of length, breadth and height, I am just writing A and A, where I have just taken the length as A, the breadth as A and the height as A. So what is a cube? We can say that a cuboid whose length, breadth and height, they are equal to each other, it is nothing but called as a cube. So you can see over here I have taken the edges of the cube over here as nothing but A, in which the length, breadth, height is nothing but is equal to A. So this is nothing but what a cube is. Now in the same way I did an activity which is related with the cuboid, in which I have taken a cuboidal box and I just open it up with the 6 faces. Now in the same way I'm just forming up a figure for the cube. So let us suppose if I'm just talking about the cube, so from a cube I can get these total 1, 2, 3, 4, 5, 6 faces. Now you can see that these are the total 6 faces that we are going to get when we have such type of a cube. And if I'm just talking about the area of each cube over here, or we cannot say a cube. We can say that they are nothing but formed up by a square. They are formed up by a square, because whenever we will take a square and we'll cut out the square from a cardboard box, and they should be of the same size and the same shape, and if I'll just stack them up in a vertical pile, then the figure so obtained is nothing but called as a cube. So these faces are all square. They are made up of square, and we know that the area of the square is nothing but side square. So if I have just taken the side as nothing but A, so the area of each square that I am getting over here is nothing but A square. So we have in total the 6 faces over here. You can count all by yourself. So if I'm just talking about the surface area of a cube, so it is quite an obvious thing for you that the surface area of the cube is nothing but 6 into A square, which is also can be said as 6 into side square. So always remember, whenever we are just talking about the surface area of the cube, it is nothing but is equal to 6A square or 6 into side square, where A represents the edge of a cube. So this is nothing but the surface area of a cube. Now let's just talk about its literal surface area. I'm just talking about the literal surface area. So there's a difference in between the surface area and the literal surface area. So what is that? So let us suppose, instead of taking all the faces of this particular cube, I'm just taking the 4 faces. I'm just taking the 4 faces. So you can see over here, I'm just taking the 4 faces over here. So what is the literal surface area? Literal surface area means the area of the 4 faces. It is nothing but called as the literal surface area. So literal surface area do exist for a cuboid as well, in which we will talk about the area of the 4 faces only, the 4 faces only, and that would be nothing but called as the lateral surface area. Now if I'll ask you that what would be the lateral surface area of the cube, so it is quite an easy thing for you to calculate the lateral surface area all by yourself, because we are just talking about the area of the 4 faces over here. So we can calculate that the total faces are 4 over here, and the area of each square is A square. So what would be the lateral surface area of a cube? It is nothing but 4 into side square, means 4A square. So the lateral surface area of cube that we will get is nothing but 4A square. And in the similar way, if I'm just talking about the lateral surface area of the cuboid, then I can also calculate, or also able to calculate the lateral surface area of the cuboid. So let's just talk about the lateral surface area of the cuboid. It is nothing but 2 into L plus B into H. This is nothing but the sum of the areas of the 4 walls of a cuboid. So lateral surface area of a cuboid is 2 into L plus B into H, where L is the length, B is the breadth, H is the height. Moreover, if I'm just talking about the lateral surface area of a cube, it is 4 into side square. We already have calculated it, and it can also be written as 4 into A square, where A is nothing but the side of the cube. So there exists a special note which is related with the surface area again. Sometimes surface area of a cuboid or a cube, they are referred to as a total surface area. They are referred to as total surface area. So don't get confused with it. Surface area of a cuboid or cube sometimes also referred to as the total surface area. So this is all about the surface area of a cuboid and of a cube.